So with notation, make sure you're clear that this is the way that we write a trig function to a power. When I want to have a trig function put to a power of 2 or 3 or 4 or something, I actually write it this way. But there's a huge frustration with notation choices that were made long before any of us were born, including myself. So you do want to be aware of the following. If you look at your calculators or some kind of Desmos or something, you will see things like this as buttons on your calculator. And you need to know that that is not exponent -1. And this is due, people get confused because of a very, very poor choice made about notation a long time ago. This is the inverse symbol. You might remember that when we write an inverse function, we write it this way, and we say this is the inverse of f of x. And it looks like an exponent of -1. And the unfortunate thing is that notation comes from that idea. Because if you're looking at multiplication, so if I have 5 times x, if I want to know the inverse operation of multiplying by 5, it's dividing by 5. And dividing by 5 is putting 5 to the -1 power. So that notation comes from the idea of a reciprocal. But when you see that show up, it does not mean reciprocal, because the opposite operation of multiplication is only one type of inverse. Inverse means literally swapping your x and y. When you use this -1 looking exponent thing, you're actually putting in things like, let's say 1/2, and you're getting out an angle. So if I told you to find the inverse sine of 1/2, you would actually be looking at, here's a y-axis. Our 3 special numbers are 1/2, √2/2, √3/2. 1/2 is actually leading you to the angle of 30 degrees. So I want you to understand that the answer to an inverse trig function is an angle. But when I look at the reciprocal function, I have a function that is still a forward trig function of I put in an angle and I get out this ratio number. This notation is referring to I put in a ratio number and I get out an angle. And this confuses people insanely year after year after year. And I'm going to keep talking about this to make until it's clear to everyone, hopefully at least. When I put parentheses and then an exponent, that means exponent. But if it is positioned here and it is a -1, it means inverse, something completely different. and I just want to clarify. That subtlety. Now, I'm going to go back over to the problem. So this is saying cosine squared, and this is saying regular cosine. And what this is creating is a quadratic form, which I'd talked about way back a long time ago, and I'm assuming most people forgot. So what I'm going to do is I'm going to make one side equal to 0, because anytime you have a quadratic form, setting one side equal to 0 is the direction you want to take. And let me give you a big, huge tip of what's going to help you tremendously. Temporarily use a letter to represent cosine theta. So maybe you choose to use the letter C to represent cosine theta. Then if I rewrite this, and instead of writing cosine theta, I write C, then this is 2 times C squared minus 5C plus 2. And by replacing the cosine theta with a C, you're able to see a lot better what polynomial you're working with. And you need to factor this polynomial. And let me take you through the factoring. Try and get this out of the way. So we're going to start with the diamond. 2 times 2 is 4. That's my A times C. And then my B is negative 5. I need to find two numbers that multiply to make positive 4, but when I add them, I get negative 5. And that would be the pair of numbers. This allows me to know how to split things up with my box division. I have 2c squared I have a positive 2, and then the diagonal that adds up to make the c term needs to add up to make a negative 5c, and I know how I'm going to split it up. And then I just start trying to figure out. I could start here and look at what will divide both items in this column. A 2 will divide those numbers, and a C will divide both of these. So I'm going to put this as 2C. Once that is chosen, the ball starts rolling. So now in figuring out what does this need to be if that's 2C, what do I multiply 2C by to get 2C squared? And then for this one, what do I multiply 2C by to get negative 4C? And then lastly, this box, C times what is negative C, and double check negative 2 times negative 1 is positive 2. I've got the factoring. The factoring is 2C minus 1 and C minus 2. Now, solving for each factor equal to 0, this factor will give me an answer of 1/2. This factor will give me an answer of 2. So I've gone through all the algebra work And now I'm ready. I've got the algebra answers. Now I need to go back to the fact that I was representing cosine with my C. I'm going to erase my factor work. And what I have is that the cosine of theta is equal to 1/2, or the cosine of theta could be equal to 2. Now it's time for the unit circle. And know that I expect you to use the unit circle. If you give me decimal answers, I will think you used a calculator and not the unit circle. So I'm going to draw a circle. And cosine represents x coordinates. My x coordinates are 0, 1 over 2, root 2 over 2, root 3 over 2, 1, negative 1 over 2, negative root 2 over 2, negative root 3 over 2, negative 1. 1/2 is this x coordinate, but 2 is way out here. One way that I told you to go about solving for cosine is to draw vertical lines, because these are specific x coordinates, and wherever those vertical lines intersect the unit circle, that is letting you know which angle you can land on and have a cosine value of 1/2 or 2. And you should see that if my answer to cosine is 2, it doesn't intersect the unit circle. There is no solution. This one will provide no additional solutions. But I have 2 equations. While there's no solution to that one, there are solutions to this one. And based on being equal to 1/2 and understanding where these two are, this is your 60-degree angle, and this one is 30 degrees after 270. And so after all that work, you finally get the only solutions between 0 and 360 are 60 degrees and 300 degrees. And that's your answer to part A. Then for part B, all you have to do is add 360n to each of those answers. And this will give you all possible solutions. And that is number 6. And I forgot to record this part. That doesn't help the people watching the video. Okay, number 9 from the homework. We are going to start off with the parent graph of sine x. Sine starts at the origin, and then it first heads up to its maximum, then it goes back to the midline, down to its minimum, back to the midline. And instead of drawing that sine graph, I want to just hold on to those 5 points and change them. I need to deal with multiplication before I deal with addition. I have two multiplication issues. I have a multiplication by -2, and I have a multiplication by a +2. The multiplication by -2 is outside the function, not inside the function with the x, like this one is. So the one that is outside the function affects y, and it takes the y coordinates of the parent graph and does the exact operation that it says. We can multiply the y values by -2. That will stretch and reflect this graph. So I'm going to first just draw the graph for y equals -2 sine x. And I want to focus on my y values are 0, 1, and -1. Everywhere that I have a y value of 0, I'm multiplying 0 by -2, and I'm still at 0. But everywhere that my y value is 1, I'm multiplying by -2, and that is going to stretch it and flip it over the x-axis when I multiply 1 by -2. Then I want to multiply -1 by -2, and that will take me to a +2. So this point is going to stretch and flip over the x-axis. And I'm going to draw that graph and then erase the extra blue points. So that's the multiplication by the -2. Now I want to work with the multiplication of x being multiplied directly by a 2. When x is multiplied by a number, I need to take my parent graph's x values and I need to divide them by that number. Trying to erase. There we go. So I'm going to emphasize that my x values of the parent graph are 0, 90 is when I'm at my low point, 180 is when I'm halfway through the cycle and back to the midline, 270 is when I'm at my highest point, and 360 is when I complete the cycle and come back to the midline. If I divide each of these x coordinates by 2, 90 divided by 2 is going to take me to 45. So the point that has that x coordinate is going to be compressed toward the y-axis by dividing it by 2. This point at x equals 180 is divided by 2, so this point gets compressed to 90. This point at x equals 270 is divided by 2, and 270 divided by 2 is going to be 135, which is halfway between 90 and 180. At 270, my parent graph is at its highest point. So that means that at this x coordinate, my highest point is being compressed in by 2. And then 360 divided by 2 is 180. So the point where I finish my cycle at the midline takes over this point, which was at the midline, but that was a halfway through. So now this is representing my very final point. And also the x-coordinate of 0 is not going to change with multiplication. Right there at the origin, that point's going to stay stable. So when I go to graph the function y equals -2 sine 2x, that's going to give me this graph. Now I'm going to erase the green graph because we're not done. But this is the result of the multiplication. Then we have one last thing that hasn't been done. And that is I have a subtraction, and it is not directly to the x because there isn't a parentheses there. So it's outside the function. That means I'm going to move everybody down 1 unit. So I'm going to go down 1 unit, down 1 unit, down 1 unit, down 1 unit, and down 1 unit. And then the graph will look like that in the end. And if we look at the homework answers, this is showing 2 cycles of the graph. I think in the directions I said 1 cycle. No, I said 2 cycles. So once you have 1 cycle, you can just repeat that pattern to show the second cycle. And if you need me to help you with that, I'm going to erase. I'm erasing too much. I'm going to have to redraw it. So I'm going to draw. No, I can't remember what it looked like. Hold on. Okay. Badoop, 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 badoop. So there's my first cycle. Then when I go to draw my second cycle, I just want to repeat this process. I can see that from 0 to 90 degrees, I went halfway through a cycle and created this piece. So that means if I start at 180 and go 90 degrees from 180 over to 270, I'm going to duplicate that exact piece. Then I'm looking at this arc occurring for the next 90-degree cycle, and I'm going to want to mimic that. And that will allow me to get 2 cycles of that function.